Welcome back to the intermediate tutorial series. I'm Chili, coming at you from the holiday season. And it's time to do the thing that I really don't want to do. It's called collision. Well, let's get at this. This might not be as painful as I think it's going to be. So first, let me tell you some things that you probably already know. Set the background. What is a collision system? What is it? Well, how is it defined? And it is defined by yours truly as such. So you've got some solid objects, and they're moving. So you do a frame update. You move your solid objects, and now you have two objects whose domains, the places where they exist, happen to overlap. And that is called collision. That is the definition of collision. So your first job is, after moving shit, you've got to check, you've got to detect collisions. And once you've detected it, you've got to do something about it. That's the collision correction. So collision system basically is broken down into collision detection and collision correction. Now, detection is super simple. It can be complicated, but for our case, it's super simple. I'm pretty sure I've explained it. Let me go over it again. To determine whether something is colliding, you do a bunch of comparisons. You compare the right side of the red to the left side of the blue. Right side's got to be greater. Oh, fuck that. Right side's got to be greater than the left side of the blue, and the left side of the red has to be less than the right side of the blue. That makes sure that we're somewhere within this range here. Now you got to do the vertical. So the bottom of the red's got to be greater than the top of the blue, and the top of the red has to be less than the bottom of the blue. If you satisfy all those conditions, then you, my friend, are the proud owner of a new set of overlapping collision rectangles. Congratulations. If even one of those conditions is not true, for example, right greater than left, left less than right, bottom greater than top, but top also greater than bottom, then you're in this range here, and you are not colliding. You've got to satisfy all those conditions, then you've got collision. So, you got your collision detected. Now comes the fun part. So if we're going to do this dance of collisions, we're going to have to have ourselves a rectangle class. I think that's the first step. So let's get on that. How are we going to make ourselves a new class? We're going to go into header files, and we're going to go add new item, header file. I don't want it to be here. Gotta go to our good old friend Mr. Assets. Can't say asset without ass. Fucking rectf. So our rectangle class is going to be called rectf. Pragma wants this mofro, and class rectf. Okay, so let's make a useful little class here to handle rectangles. Public. I'm going to make the data public on this one, because it's a very basic kind of, almost like an integral type here. Float. Top. Float bottom. Float left. Float right. So there's our data, the four positions of the rectangle sides. I don't know how you guys think about rectangles, but how I usually think of them is, let me find my pen. So if I got a rectangle, I generally think of it in terms of 2 points. these points here. This point would be left comma top, and this point would be right comma bottom. It helps to think of a rectangle in terms of being defined by 2 points. So that's how I think about it. Now we need some functions here for our rectangle. Let's public this motherfucker. Alright, float, top, bottom, right. Just our basic constructor here. So top, bottom, bottom, left, left, right, right. Okay. Bada boom. And let's make another constructor. And this will be a copy constructor, copying from another rectf object. Now I can reuse this stuff here. If I play my cards just so. Now I gotta go rect.top. And I gotta copy that, paste it in here, 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 and we're all copied out. Good job, everybody. Give yourselves a pats on the backs. Okay, so I'm gonna add one more function because it's gonna be useful. I'm gonna call this one translate. Float dx, float dy. And this function here is just going to basically do what it says it's going to do, which is more than you can say for most politicians. Bada bing. So if I'm going to translate by dx dy, what that means is I'm going to move dx in the x direction and dy in the y direction, translating to a new point here. But I digress. First of all, let me not fuck it up with drawing on the wrong layer. And let's get a new color because we like color. Color is our friend. And let's move our layer to the top. The better to see you with, my dear. Okay, so yeah. You got your dx, your dy, and that will just move your rectangle to a new position. And how we do that is we go top plus and equals dy, bottom plus and equals dy, left plus and equals dx, right equals dx. So still a little useful function that will make our rectf class that much sexier. Alright, so let's try protected, just in case I want to inherit from rectf somewhere down the line. Okay, so we have our rectangle class. Actually, no, fuck it. I'll do that later. Don't mind me. Chili's just talking to himself again. He does that. That is a thing that he does. Okay. So now we've got to put this rectangle and integrate it into our sprite. We're going to integrate it into the sprite core. Like so. Well, first we've got to include it, I guess. That would be helpful. Rectf. Now we create a rectf here. What are we going to call it? We could call it the collision rectangle. We'll call it crect. Sounds like the name of a trailer park rapper. C-rect. Like K-Fed. Okay, now we need a function here. Now, the problem is if we get C-rect here, if we try to use it, like, how to explain this? You remember how where is my thing here? So let's say we got a sprite, and it is at a certain point. There's our sprite. Now you remember how we defined our surfaces, our surface sequences, such that they had a relative drawing point, which is relative to the point of the sprite. So if the surface is like this, right, this is our position of our sprite. To find the top left corner to draw the surface at, our surface sequence would take the point of the sprite and add to it the offset, or whatever you called it. I forget what you called it. I could look it up. I could look that shit up for you. Where is it again? Surface sequence. Base X, base Y. Yeah. So that's a thing that happened. So I mean, base X and base Y, you got your surface. It's defined as some point here, and to find the point to draw to, you take your current position and you subtract your base X and base Y, and you get your drawing position. So the moral of this story is that the sprite's X position is not defined at the top left corner, but rather at basically at the base of its feet, but it can be defined wherever we want it to define it. Now we have to do the same thing for the rectangle doodlehickey, the collision rectangle, the C-rect. We also have to define it relative to this base point, which is located around the feet of the player. And here's the thing. That's going to be defined relative to this point here, but as the player character moves in the world, the values for the collision rectangle are going to stay the same, right? So I mean, if this is our Y, this is our X. Collision rectangle is probably going to be defined something like what is this, X? I don't know, 10, 0, and here maybe like negative 60, negative 10, right? And no matter where the player moves in the world, that's going to be the coordinates of the rectangle. And that's not a good thing, because if the player is moving over here, and then we try to do a comparison for collision purposes, we will find that we're not colliding, even though we are colliding, because our collision rectangle is not being updated. I think I spent way too much time explaining this thing than I should have. But that happens. So, what is Chili trying to say here? What he's saying is that we can't just use the value C-rect as is when we do our collision tests. We have to add X and Y to C-rect to get our the current position of our collision rectangle. So we'll make a function for that. No, that's not good. We're going to call this rectf get C-rect. It'll be constant, and we'll make it right in the sprite core. And all we're going to do is create a new rectf based on crect. So we're going to copy crect. Then we're going to do rect dot translate x and y and return rect. And that, my friends, will give us our crect. And everything will be fine. All will be well in the world. Now, this thing never changes, so I could make it constant. But if I did that, I'd have to make a constructor for sprite core, because you can only initialize constant members in the initializer list of a constructor. And I don't want to do that, so I'm not gonna. But, you know, I probably would if I weren't, you know, on the clock here, as it were. So let's go into sprite. And we don't need sprite. Let's go into player sprite. Yeah, there it is. And let us core dot let's see what we got here. crect dot did I make those things protected? I wanted to make them public. That was dumb. Let's go to rectf. Let's make this public. I don't know why I did that. And let's go back here. So top. I'm going to say the top is at negative 60. I have no idea, really. I'm just guessing. We'll figure it out. Core.crect.bottom is equal to 0.0. Core.crect.left is equal to negative 10. Core.crect.right is equal to positive 10. Alright, so we initialize our rectangle, we do our stuff, and we do the hokey pokey, and we turn ourselves around. That's what it's all about. Error, sprite, no default constructor available. I think the problem here is that I didn't give a default constructor for rectf, so it's looking to be constructed with one of these constructors. You know, because I'm embedding it into sprite, right? Sprite, or sprite core, has an embedded crect here. And yeah, but it doesn't have a default constructor for that. So we're just gonna do this. We'll do that, and we'll just leave it. Let's try that now. How you like me now? Fatal error. Well, well, well. Call rectf. Oh, okay. Duh. I say duh. And we got ourselves an application, and it should work exactly the same way it worked before, because I didn't change anything that actually would make a difference. Let's do that now. So for shits and giggles, let's add another function to rectf. We're going to call it draw. Wait, let's go up here. Class. What now, son? What? All right. I gotta get serious here. It's obviously not class. It's obviously include D3D graphics. My mind wanders. You know how it is. Getting old. D3D graphics GFX const. Now let's draw some shizzle. GFX dot draw line. So we do how are we gonna do? We're gonna do float x1 is left, float y1 is top, float x2 is right. Why did I do float when it was obviously got to be an int? Y2 is bottom. Now red is 255, green is 0, blue is 0. There we go. Now let's correct this. Okay, now this is not what I want to draw, because that'll just draw a diagonal from the top left corner to the bottom right corner. What I want to do is I want to draw the top line, which is going to be left, top, right, top. Copy this, go down. Now I want to do right, top, right, bottom. Can you guess what that line that one is? It's the right line. Now I want to do left, bottom, right, bottom. And for the piece de la resistance, I want to do left, top, left, bottom. And this will draw the rectangle. So I guess you guys can see where I'm going with here. I'm just gonna make a little thing where I can draw the rect F just to see how it looks before we move on with the show, the freak show. So I'm gonna go to sprite and what we got here? Draw. I can go for that. Go to definition. Alright, let's shake things up a little bit here. We're going to draw our sprite, and then we're going to go draw core.crect.draw GFX. No, we're not going to do that, because that would be stupid. Well, let's see. What do you think will happen when we do this? I think you know what's going to happen when we do this. Shit's going to pop off. You can look right over here. We've got a little bit of a red line there, and that's it. Because the rest of it is up here. Because we did the thing that I said that we're not supposed to do, which is use crect as it is rather than translating it. See, that's one of the reasons why it's a good idea. It would have been a good idea to make crect private, because then you couldn't fuck yourself up like that. You'd be forced to use the function get crect. But I didn't do it because I was lazy, and that sometimes makes big headaches for you. I was lucky this time I caught it. I even caught it before I ran the thing, but I still ran it anyways to show you guys. So this is our collision rectangle. As you can see, it's not perfect, but it gets the general center of our character, I guess. I mean, I can move the left one a little bit more to the left. I can move it up 2 pixels or so. Let's do that. So we'll go to player sprite. We'll move the top up by 2 pixels. We'll move left by 1. And do the hokey pokey. We'll turn ourselves around. That's what it's all about. I already said that. I can move it down by 1 actually. I don't know. I kind of like this. Whoa. Oh, we're going off the side of the screen. There we go. Alright. So, yeah. Move this one down by 1. I'll leave it at 10. I'll make it symmetrical. Build. So there is our collision rectangle for our sprite. But by itself, it's not really much to look at. We gotta do something with that shit now. So let's do something with that shit. Now the thing, obviously, we're gonna have to do is we're gonna have to add rectangles to our bam bam. There we go. Add rectangles to our tiles, right, in our tile map. So we could, here's a proposition for you guys. Let's see if you agree with me. Here is our grid of tiles. I'm making fewer tiles here just because I'm lazy. And I don't think you guys want to watch me draw out like 50,000 tiles on the screen. So that would be retarded. So let's say this is our tile map. The black is our tile map. The blue is our sprite. Alright, so the million-dollar question is, how do we determine which tiles, if any, our sprite is overlapping with? Now the most apparent answer, the naive solution, would be to give each tile its own rectangle member, and then do a overlap comparison between the sprite and every tile in the tile map. And that will certainly get you your answer. But if you have a huge tile map, your answer is going to take a fuck ton of time. So, is there a better way? And the answer is, of course there is. Otherwise, why would Chili be ranting on like this? Because, you know, Chili never rambles on for no good reason. Never, ever. Anyways, so the way we do it is we're going to exploit the regularity of this grid. This grid is uniformly spaced. It's very, I don't know what the word is, regular, symmetrical. Often when you have a system like that, that's a hint that there might be something that you can exploit. And there is something. Now because our grid is nice and regularly spaced, we can do something with that. Say we got a point here. Let's say the top left hand point is I don't know, 3560. So this point is 3560. Now given the position of any point, we can figure out which tile contains that point simply by dividing by the width and height of a single tile in the tile map. So for example, let's say width equals height equals 25. So we divide, let's see, so our index, our x index, ix, which is the x coordinate in the tile map, not in space, but in the map itself, would be equal to 60 divided by 25 as an integer. It's an index, so you don't have an index of, you know, points, would be 2, right? And iy would similarly be 35 divided by 25 equals 1, right? Because you round down. And that's what you get. So your index into the tile map is 2, 1, which is correct, right? 0, 1, 2, 0, 1, 2, 1. And you do the same thing for here, and you would get 1, 2, 0, wait, 1, 2, 3, 1, 2, 3. So this one here, this is 2, 1, and this is 3, 3. So now we have the tile map indices of the tiles which contain our top left and bottom right points of our collision rectangle. Now that we have that, we can just loop from here. Oh, wait, undo that. We just loop from right to left, going like this, zigzagging from the top left to the bottom right. And if we loop through all these tiles here, we have all the tiles that we're overlapping with. And then the only thing we have to do is check whether they are solid or not. Are they solid or are they passable? And depending on that, if they are not passable, if they are solid, then we have a collision. But if they are passable, no collision. So we didn't have to do a single overlapping test. All we do is we convert a couple points into tile map space, into the indexes in the tile map, and then loop from the top left to the bottom right point, and we're done. So that is, my friends, that is how we do. And we don't do these tests, so we don't even need to include rectf into tile. We don't have to do that. Not necessary, which is good, because rectf, a single rectf is 16 bytes. So if we had a big tile map, like we might have like 32 megabytes of just rectf alone. We can save by not including it into tile. So that is the theory. Let's do le coding. See, I said le coding because that makes it French. Alright, now this is the thing that I am not good at, which is thinking of what I'm supposed to be doing. Talking and thinking. Not good at it. Okay, so we're gonna need we're gonna have to go to tile map. I guess it all starts at tile map. Let's start at the top down. So we're gonna make a function, and it's gonna be, okay, this is dumb. Constant void. I fucked that up. I noticed this before and then I forgot to change it. We gotta change that shit right now, because that's dumb. And we'll go to tile map here. Where is the bullshit? Here it is. Because it's not, we're not returning a constant void. What does that even mean? Constant void. A void is nothing. So it doesn't matter if it's constant or not. What we want is we want to say that the function is constant. It doesn't change the state of the object. So I fucked that up a little bit whenever I wrote it. I'm sure some of you guys caught me. I hope some of you caught me. No, we're going to do a void. And this is going to be called get crects. Get colliding rectangles. And it's going to pass two things. It's going to pass a rectf, which is the collision rectangle of the sprite, and it's going to pass one more thing. A little interesting little tidbit that I have to do up here with a type def. What are we going to define here? We're going to define rectf list. If we're going to make a list, we need to include nope, list. Rectf list std list rectf. How's that? You don't like it? Include rectf. How do you like me now? Just fine. Okay, so we have a rectf list, which is a list of floating rectangle objects. What we're going to do is we're going to pass this thing a reference to a rectf list. And this function here is going to fill that list with rectfs of the whatchamacallits, of the tiles that we're colliding with. So now we've got to do the stuff. Going into the tile map, making the code, solving the problems, working together. Tile map. Boo. Tile map. Haha. Screwing myself over with capitalization. Always fun. Get C. Why does it not like get C rects? You get wrecked. Okay, it doesn't hate it. Wait, what? Error type. Type define. Is it backwards? Is it supposed to be like this? Because I could see it's supposed to be like this, perhaps. How's that? Oh, you like that? Oh, you love it. Okay, let's try it again. Yeah, get that. Ugh. Okay, you don't like it. Whatever. I'm just gonna copy and paste. All this coding is taking up my video time. Okay. Now, my friends, we do the coding. Now the question is, how do I want to take care of business? Take care of business, as they say. Tile. Private width and height. Alright, so inside of tile, we're going to make some functions. Static int get index x, float x, it doesn't have to be constant, return x divided by width. Static int get index y, float y, G-I-T, yeah. Booyah. Okay, this will get us our... Ugh, that was nasty. Whoa, not much better. Okay, so we get our index x, get our index y. That's a start. Let's use that start. Okay, so we need a couple of for loops, right? To loop through our tile map indexes. So, int ix is equal to, this is our starting x index, and that's going to be equal to c rect dot left it's going to be tile get index x and then ix end is equal to get tile get index x c rect dot right. Okay, this is good, but I actually want my I want my while loop to be on the outside, because I always like to loop first right, left to right, and then top to bottom. So we do the same thing kind of, but kind of different. Let's see if I can copy and paste without fucking myself over. Index y top I y end index y bottom. Did I fuck it up? Scream really loud at your monitor if I fucked it up, because then I'll know for sure. I will hear you through the internet and time. Okay, now we need, as long as iy is less than iy end iy plus plus. Here, as long as ix is less than ix end ix plus plus. Good. Are we kosher? I believe we are. Okay. So let's do our magic in here. So here's where we actually do the list. So for each of these, we go if let's go to tilemap.h. Let's make a little function here for the funnies. For the fun of it, I'll call this one int get 1d index int x int ix int iy const. This one will just return the one-dimensional index based on two-dimensional ones. So we'll do ix plus width times iy. Is that good times or what? I believe it is. If actually, I got a better way of doing that. Let's do tile pointer to. Yeah, sure, we'll do pointer. Get tile we'll make this private for now. We don't want anyone just to mess around with our tiles like that, do we? No, we do not. And then we're going to do it like this. Return tiles at this index. There we go. That's even better. That's way sexier. I'm not sure if I'm allowed to make this constant though, because the tile isn't constant. Well, we'll see. Maybe I'm allowed. Maybe I am forbidden. Okay, so if get tile ix iy pointer to Okay, we need another function in here. Ugh. Tile also has this dumb typo. Gotta get rid of that. Gotta change constant void draw to void draw const. Woe is me. The things I gotta put up with in life. First world problems. Alright. I'm just going to make another public thing here just to separate these two. These are the statics. These are the non-statics. Okay, we need bool is passable. Const return passable. Wait, is passable? Yeah, passable. Okay. Okay. Let's go back. There you go. So if get tile at ixIy is passable, I think I can do this. List dot push back star get tile ixIy. Can I do it? Doesn't like it, does it? Matches the argument list. Right. The list is a list of rectfs. So I need to get the actual collision rect of that particular tile in order to put it into the list. Now here's the rub. So tile doesn't actually store the collision rect. So I need to generate it on the fly. So I do static rectf get crect int ix int iy. So based on a couple of indexes, I should be able to generate the old rectum. And how I'm going to do that is rectf create myself a little rectangle here. Now we need to generate the stuffs. So float. So what is this is the dimension of the top. It's going to be iy times height. This should make sense to you guys. What's the next one? I need my help here. Help! Send help! Bottom is iy. Do it like this. Iy times height plus 1. Not times 1, plus 1. And then we got ix times width and ix times width plus 1. And that should give me my rectangle for that particular tile. Should it not? Agree or disagree? So in that case, what we want to do is we want to do tile get crect IXIY and push that onto the list, and that works. That works fine, my friends. That works more than fine. Fan-fucking-tastic, my friends. Now, let's try to build it. Trial by compiler. And we get errors, of course. We get errors. Wouldn't be programming without errors now, would it? Missing... Why are you missing? Static rectf get crect. Ah. This is dumb. I'm not sure if this is actually the thing, but it was dumb anyways, so let's fix it. Get crect missing return type assumed to be a member function returning it. What? I'm returning a new rectf. What is... I'm just making... Ugh! Are you gonna make me do stuff? Because goddammit, I hate doing stuff. Just leave me alone already. I just wanna sit here drinking my Sprite, talking to myself. Last day before work. I could be playing the game. Okay, what's your problem? Missing blah before get crect. You probably don't know about rectf. Wait, but if you didn't know about rectf, this would be like underlined, wouldn't it? Well, I guess you don't know about rectf. Include rectf. I don't know why that wasn't underlined then. IntelliSense, you have failed me for the last time. Conversion. That's a warning. Wait, did it work? Oh, it actually worked. I just assumed there were still errors. Anyways, yeah, so I don't need... I can do this now. Ha ha ha. Because fuck you. This doesn't change anything in the end, actually. It probably generates the exact same code, but I just like writing it this way. I just like it for some reason. Gives me a little bit of a boner. Just a little one. Just a little bit. Okay, so that is tile getting this rect. What did I do? Oh yeah, I made the function that filled a list with colliding rectangles. So now that's a thing. Now let's go to Sprite. Let's make a function to get the colliding rectangle from Sprite. So we go rectf get crect const return core dot IntelliSense got get crect. There. Alright, so that allows the top level to get access to the collision rectangle. Now let's have fun. Let's do shenanigans, people. We're not going to actually do the collision yet, but we're going to what's my thing? What's my name? Who's your daddy? What's his name? I want to go to game. But I want to go to game.cpp. Okay. Now here's the trick. we're going to draw our tiles. Then we're going to do, what was the name of the list? RectF list. We're going to go T dot get crect. Actually, leave it the name it is. I was going to rename it to get crect list, but fuck it. P dot get crect, and we pass it our list. It fills the list, hopefully, and then we go for I in no. So now we're going to loop through a list. I don't know if I talked about this before, but you can loop through a list using something called an iterator, which is kind of like a pointer that runs through the list for you. Here's how we do it. We're going to make an iterator variable. So we go rectf list, and we go down here to iterator. And we call that I is equal to list dot end. End gives us the iterator pointing to the end of the list. Wait, we don't want that. We want begin. Is it begin? I can't remember now. Begin. There we go. And then we want to create another iterator variable. End is equal to list dot end. And then it's just a normal for loop. So as long as I is not equal to, you can't do less than with iterators, I don't think. You do I is not equal to end, and then you just do I plus plus. And it will iterate through the elements of the list. You can look this shit up on the interwebs if you don't believe me. It's all there, people. Alright. Now we've got our iterator iterating through the list. So we go I, and if you want to access the thing that the iterator is pointing to, use a pointer thing. I draw GFX, and we're going to draw all of the rectangles of the tiles which were found to be in collision with our sprite. So looking back over my footage during editing, I just realized that this is the first time I'm covering the STL containers. And for a first time, I think I kind of glossed over it. So let's go a little bit more in depth. Now, here's the first line I typed in regarding the list, and it's a type def, which is just a way of kind of defining an alias for a data type. So I don't want to type this in every time. Oh, fuck off. I don't want to type this bullshit in every time. So I give it an alias called rectf list. So that part is simple. You can do that for anything you want. That's nothing specific to templates. The question is, what the fuck is this thing? Okay, so let's break it down. First we have our std scope resolution here, std and the scope operator. And this tells us we want something from the std namespace. Most of the STL stuff is in the std namespace. Why std? Why not STL? I have no fucking idea. But that's the way it works, kiddies, so that's what you got to use. So first we say we want something from the STL. And then we say, what do we want? Well, we want a list. Very standard container. It's kind of like a linked list. It operates very similar to a linked list. And here is the big portion. This is the template argument. This tells us what kind of list we want. So that's the magic of the standard template library and templates in general, is that we can have a list of whatever we want. We can have a list of ints, we can have a list of pointers, we can have a list of rects, we could have a list of sprites. All we have to do is change the thing in the template. Remember when we made our own linked list in lesson 1 of the intermediate series. We made a linked list for scores, and that was great. That worked fine, but it only works for scores. If you want a linked list, if you want to use that to have a list of, say, rects, you can go fuck off, because you're not getting it. You're only getting scores because that's what we wrote. But with templates, you get what you want. Sounds like a fast food commercial. Now, so that's this whole thing here. These angle brackets, they tell us the kind of object that the list is going to store. Let's move on, friends. Next thing here, we have the first time we really used the list, and that was just a pushback. Let's add a new item to the end of the list. Very simple. You push back to add new items to your list. Now comes the more interesting part. Here, we create a new list. We pass the list by reference to this function, and the function fills the list in for us with rectangles. And now we have to draw all those rectangles. So we want to go through each item of the list. And a very common way, one of the main ways to access the items in a container, is to use an iterator. So we create an iterator here, and you just do that by going the name of your container type, and then scope operator iterator to create an iterator object, and create our iterator, and we set that iterator to the beginning of our list. We create another iterator for the end of our list, and we keep iterating. Did it again. We keep iterating through our list until we are at the end. And for every iteration, we draw the rectangle, right? Now, iterators have a little bit of nice operator overloading to them. So when we use the pointer operator on an iterator object, it actually gives us access to the members of the item that the iterator is pointing to. So very clean interface there, very nice to use, and that's it. So I used a list here because, I mean, normally if I have to dynamically allocate memory, I would just use an array of pointers, right? But if you don't know ahead of time how many things you have to put in that array, you don't know how many there are, you can't really properly define the array. You don't know how much memory to allocate. And that's where I really like these STLs, these STL containers, is because, I mean, I don't have to know how many things I have. I just push back into it and it's fine. You push back and you're done. And then when you're done, you iterate. So that is STL containers in a nutshell, or at least the list container. There are others. Vector is another, probably even more commonly used one. But that's a story for another day. So I hope this gives you a little more insight into containers. I'm sure we'll be seeing them again in future episodes. And now back to your regularly scheduled tutorialing. I like it. Now, I don't think this is going to work, but it might work. The reason I don't think it's going to work is nothing ever works the first fucking time. Look at that. That is fucked up, people. That is basically the definition of fucking up. But it's kind of almost right. It's like it's getting there. Yeah, we just need a little bit more. We just need to debug this mother. Alright, so if I were a bug about collision rectangles, where would I be? I think I would be in the place where I was making the collision rectangles, which was in tile, I believe. Get C rect. IY times height plus. Yeah, that's the problem. There it is. We don't want height plus 1. That doesn't make any sense. That's just a little bit. We want the index and then the next index over. Thank you very much. I told you guys to yell at me if I was doing something wrong, and I didn't hear shit. So I'm gonna blame this one on you. This one's on you guys. Alright, how is that? Rebuild. That was a fuck up. I should really take care of all these warnings. But I'm not gonna. Alright. This is kind of better. But not really, because I mean, we're still... First of all, we're only getting the ones that are supposed to be passable. That's backwards. And second of all, we're only getting half of them. We're not getting the ones for the right-hand side. Now, I think I know the problem, the reason why that is. And that is, my friends, the song that never ends. Let's go down here. Yeah, you see, the thing is here, we're going until IY, as long as IY is less than IY end, but we want it to be less than or equal to. Is it like that? Was it the other way around? Right? Because that's the way we want it to be. Less than or equal to that index. Normally we use the width, right? So if the width is, say, 5, the indexes are going to be 0 to 4. But in this case, we actually have the index of the last cell that we want to process. So we have to do less than or equal to. Now this should change that. Now we want it to be if it's not passable. So we want to invert this. Let's just do is passable for now, because that'll show us a good little thing here. Okay, and now we have the answer that we seek. You see this? So this is drawing the actual list of rectangles that was found by our function. And as you can see, it does a good job here. It's not finding the black ones because we have it inverted, right? It is inverted at the moment. It's only finding the ones that we can pass, that we're not colliding with. So right now it's drawing the rectangles which we are overlapping with but not colliding with. Now let's do the thing we're supposed to do. We'll go here. We'll make this a knot. There. Now we're getting the rectangles that we're actually colliding with. Now this is dangerous because, as you can see here, the very bottom line is actually getting drawn off the screen. So if I go right too far, I get access violations because I'm drawing off the screen, which is always not ever really a good thing. Well, let's stop this, and just for shits and giggles, let's go to game. No, we'll go to player sprite. And we'll take this one down to, let's try 375. Wait, I gotta go to game.cpp. There we go. This is why it's never good to have like magic numbers just in your code. You change it in one place, you don't change it in another, and you get F'd in the A. Or you change it differently in two different places. Also good for an effing in the A. Let's try that. There you go. So now you can see how we collide. So a nice little graphical representation of our collision detection. But now, my friends, comes the super fun part. And by super fun, I mean like pull your hair out and bend over, kiss your ass goodbye fun. Because now we've got to do the actual collision handling. What is it? Collision correction. I think that's what I decided to call it. So Chili's just sitting here chilling out on YouTube, thinking to himself, and he's thinking that this would be a really good point to end this video. We've just finished collision detection, and so next video we can start fresh on collision correction. How does that grab you people? It grabs me fine. My jimmies are unrustled. So I will catch you guys when I catch you guys next. See you then.